Hello everyone, welcome to this session. As we know that supervised learning is mapping inputs to outputs. So in this session, we will see the first step and the key concepts in this step, data representation. First, let's review the machine learning procedure, right? So how to develop a machine learning model? We can say we have the following steps. The first step, we need to represent the data. So machine learning model must understand the data. So this step is to translate the data to the language that the machine learning algorithm can understand. So we call this one data encoding, right? Data encoding. So then after this step, we can select the machine learning algorithms. Maybe we ask ourselves to use a parametric or non-parametric machine learning algorithms. Then we will train the model. So after the model is trained, we can evaluate the output to make analysis of the prediction errors to see if the model works or not. So let's use an example. Still the food classification. The training data is here. Then we need to represent the data to make sure the machine learning algorithm can understand the input and output. Then we will select the machine learning algorithms. Then we will train the model. When the model is trained, we need to evaluate if it's good or not. So if it's good, then we can apply this model. So for a new input, this new input, not in the training side, then we do a prediction using the trained model, then we will have the output, right? So this is a procedure. So in this section, we talk about the first step, represent the data. So we can see in the flow is here, right? How to represent the data to let the machine learning algorithm understand it. So before talking about that, we first need to understand the different types of data in machine learning. The first kind widely used, numerical data. So numerical data, these are the data that can be represented by numbers, and you can add, subtract, multiply, or divide. So such data, so to carry out arithmetic operations. In the numerical data, there are two kinds of them. Most widely used, we call them continuous data. So for example, the height is 177.4 millimeter, right? The velocity is 18.44 meters per second, right? So these are the continuous data. So this data, continuous one. The second one, we call them discrete data. So the data with countable fixed elements. So for example, the number of students is 30, number of students is 40, and the age is 25. So those ones, we call them discrete data. Right, so don't mix the discrete data with categorical data. So for example, the number of students is 20, and this is a handwritten digits recognition in the last session, right? So we have a handwriting one, we want to recognize which one it is. So both of them are integers, but they are rather different. So for the first one, number of students is 20. This is numerical data, although it's discrete integer, right? So we can say, okay, the number of students of class 1 is 20, and the number of students of class 2 is 25, and the sum of them is what? So we can do arithmetic calculations to them. But the second one, this is different. This one, the handwritten digits recognition, although these are numbers, right? But they are the categories. So we want to see if which handwritten number belongs to which category, right? Which category. So although they are numbers, so they are categorical data. So don't mix them. So we can't do the arithmetic calculation among them because these are different categories just, right? So we need to pay attention to this. So numerical data, if it's an integer, we can do it using regression. But if it's a categorical data, we can do the classification, right? So this is a thing needs to be paid attention to. Then in contrast to numerical data, another kind we call it categorical data, right? So this kind of data, we can store them into groups or categories. So normally we say the output are labels, right? Or sometimes we call them names. For the categorical data, we also have multiple types. So for example, binary data, true or false, yes or no, right? So we can encode them with 0 and 1. So true is 1, false is 0. So this is quite straightforward. Another kind, we call them nominal data. So sometimes we call them naming data. So for example, the name of a person, the name of a state. So these kinds of things, we call them nominal data. Another kind, we call them ordinal data. These are also categories, but they have relations. So they can be ranked, they can be ordered, and we can read them. So for example, for a restaurant's menu, we can say strongly dislike, neutral, like, strongly like. So this one different from nominal data. The ordinal data can be ranked, while nominal data can't rank. For example, you can't rank Julia and Jack through some way, right? So this is not possible. So binary, nominal, ordinal. So these are the categorical data, right? So let's see that in this example, the previous finance prediction example, right? So we can see which are the, what kind of them are they? For the R&D spend, we can say this is what? Numerical data, right? And the state, this is what? This is categorical data. So is it nominal or ordinal? So this is nominal, right? That's nominal data. So they can't rank. So New York, California, Florida, they can't rank. Okay, so for numerical data is quite straightforward for the machine learning algorithm to understand. But for categorical data, so how to represent them? So now we will talk about the encoding of the data, of the categorical data. So we have said that for binary data, it's easy, 0 or 1, right? Now let's see the ordinal data. For ordinal data, as we have said, they can be ranked, right? So based on this property, a simple way is to assign each of them to an integer value. Because they can rank, the integer value can also be ranked, right? So we can make such a mapping. So maybe we can start from 0. So for ordinal data, let's say this example, the strongly dislike, neutral, like, strongly like. So what we can encode, we can do this. Ordinal encoding, we use integers for them and start from 0. So we can see like this. Strongly dislike, we put it as 0. Dislike, we put it as 1. And strongly like, we put it at 4. So this also has a rank to represent this ordinal data. So now we have solved the binary and ordinal. The remaining one is a nominal data. So how do we encode that? We can see like this. There is a data point D, so we can encode this nominal data D to a binary vector. So V from V1 to Vk, and K is the number of the categories in the data set. So what we do is that if D is the ith category, then Vi will equals to 1. For all the others, this will be 0. So are you familiar with this one? Right. So we have discussed it before in the first course of this specialization, the MATLAB part, right? So this is what? One-hot encoding, right? So at that time, we have talked about how to write a custom function and how to call the MATLAB built-in function to encode this data, right? So we can review them. So if we have the red, green, blue, 3 colors, we want to do one-hot encoding. So according to the definition, only when D is the ith category, Vi equals to 1, all the others are 0. So we can see what? For red, the first one is 1, all the others are 0. For green, only the second one is 1, all the others are 0. So blue, the last one. So this is one-hot encoding. Another method to encode the nominal data, we call it dummy encoding. One-hot encoding is straightforward, but it always have one column of redundancy. So that's why the dummy encoding is proposed. The dummy encoding, this time we don't generate k binary variables, but k-1 binary variables. So let's see again the same example. We can see if we do the dummy encoding, it's like this. So red is 1, 0, green is 0, 1, blue is 0, 0. Right, so this is called dummy encoding. So you can check more help files, to see how to encode this one. Yes, and you can write it in a mathematical function or custom function to see how to carry out dummy encoding. So if we give some examples, New York, California, Florida, Washington, so these 4 cities, if we do one-hot encoding, we can see the 1 only belongs to this category is 1, 1, 1, 1, all the others are 0. So if dummy encoding, how to do? Not 4 elements, 3 elements in the vector, right? So 1, 0, 0, 0, 1, 0, 0, 0, 1. The last one is 0, 0, 0, right? So this is a one-hot encoding and dummy encoding. So that is the encoding of the data. So thank you very much for listening. Okay, thank you. Bye-bye.